Breaking news from SpaceX. A new giant emerges in the heart of Starbase, Texas. A revolution is quietly taking shape. While the world still marvels at Starship 5-2's historic first flight, SpaceX engineers are already pushing the boundaries even further. The next evolution of humanity's most powerful rocket isn't just on the drawing board, it's rapidly becoming reality. Welcome to a pivotal moment in spaceflight history. Starship 5-3 is emerging from the shadows, bringing with it unprecedented capabilities that will redefine our journey to the stars. This isn't just another iteration, it's a complete reimagining of what's possible. Recent developments have accelerated this transition more than anyone expected. The challenges faced during Flight 7, rather than setting SpaceX back, have catalyzed innovation. NASA's own Lisa Watson-Morgan recently revealed that V3 could debut by year's end, months ahead of initial projections. But why this rapid shift from V2 to V3? The answer lies in SpaceX's ambitious 2025 launch schedule. 25 flights that will push the boundaries of what's possible in space. At the core of this mission lies a critical challenge: orbital refueling. To support NASA's Artemis program and future Mars missions, SpaceX needs a vehicle capable of not just reaching orbit, but serving as a cosmic gas station. Today, we're pulling back the curtain on V3's revolutionary design. From its towering 150-meter height to its groundbreaking propulsion systems, every aspect of this vessel has been engineered to overcome the limitations that have held humanity back from becoming a truly spacefaring civilization. Here on Elon Musk's 24 Hours, we're about to explore how Starship V3 will transform the future of space exploration. Let's dive right in. The dawn of a new era in spaceflight began with an explosion. As Flight 7's fireball lit up the Texas sky, it didn't mark an ending. It sparked a beginning. In those crucial moments after stage separation, as engineers watched their creation fall apart, they weren't witnessing failure. They were seeing the future take shape. That future is Starship 5-3, and it's revolutionizing our path to the stars in ways few could have predicted. The story of V3 isn't just about bigger rockets or more powerful engines. It's about humanity's unwavering determination to reach beyond our earthly bounds, and SpaceX's relentless drive to make that dream a reality. Let's start with what makes V3 different. Standing 150 meters tall, nearly half the height of the Empire State Building, this behemoth dwarfs everything that's come before it. The Super Heavy booster alone stretches 80.2 meters, while the Starship portion adds another 69 meters of engineering marvel. But size isn't everything. It's what's inside that's truly revolutionary. The numbers tell a story of unprecedented power. V3's enhanced propulsion system will deliver over 10,000 tons of thrust, enough to lift 200 tons of cargo into orbit. To put that in perspective, that's equivalent to launching the weight of an entire Boeing 747 into space, every single flight. But the real game changer lies in V3's fuel capacity. The Starship segment will carry 2,300 tons of fuel, 800 tons more than V2. The Super Heavy booster pushes these boundaries even further, holding 4,500 tons, an increase of 750 tons over V1. Combined, that's 6,350 tons of fuel powering humanity's greatest leap into the cosmos. Why does this matter? Because SpaceX isn't just building a bigger rocket, they're building the foundation of an interplanetary gas station network. NASA's Artemis 3 mission to the moon demands something unprecedented: the ability to refuel spacecraft in orbit. This isn't a simple task. It requires precision engineering, perfect timing, and a level of coordination never before attempted in space. The current plan calls for up to 10 tanker missions just to fuel a single Starship human landing system. Each of these missions must be executed flawlessly, transferring cryogenic fuels in the harsh vacuum of space. V3's increased capacity means fewer missions, reduced complexity, and a higher chance of success. But SpaceX isn't stopping there. They're developing two potential approaches to this orbital refueling challenge. The first involves direct ship-to-ship transfers, a delicate dance of two massive vehicles connecting in orbit. The second, more ambitious plan envisions an orbital fuel depot, a permanent gas station in space that could transform our ability to explore the solar system. Learning from the past has been crucial to V3's development. Flight 7's premature end revealed critical vulnerabilities in the oxygen system and engine firewall cavity. A catastrophic pressure increase led to failure, but it also led to innovation. V3 incorporates enhanced heat shield technology, improved navigation systems for the forward flaps, and crucial upgrades to the Raptor engines. These aren't just incremental improvements. They're quantum leaps in spacecraft design. The heat shield modifications alone could revolutionize our ability to protect spacecraft during atmospheric re-entry. The navigation systems represent the cutting edge of aerospace technology, while the engine upgrades push the boundaries of what we thought possible in rocket propulsion. The timing of V3's debut couldn't be more critical. The space industry is entering its most competitive era since the 1960s space race. Blue Origin's New Glenn has already reached orbit. Rocket Lab's Neutron is preparing for launch. United Launch Alliance's Vulcan is finally nearing certification. Across the Atlantic, Europe's Vega C has resumed operations, and Ariane 6 is preparing for its inaugural flight. Even China has entered the fray, with a wave of new rockets bearing striking similarities to SpaceX's designs. The Zhuzhou 3, Tianlong 3, and Changzheng 2 are all set to launch this year, each one pushing the boundaries of what's possible in spaceflight. But V3 represents something different. It's not just another entry in the space race, it's a paradigm shift in how we approach space exploration. The engineering challenges alone are staggering. The quick disconnect mechanisms and couplings required for cryogenic fuel management push the limits of material science. The navigation and docking systems demand precision beyond anything previously attempted. Consider the complexity of orbital refueling. In the vacuum of space, with temperatures fluctuating hundreds of degrees between sunlight and shadow, SpaceX must transfer supercooled fuels between massive vessels, traveling at 17,500 miles per hour. The margin for error is zero. The consequences of failure are catastrophic. Yet V3's advanced systems make this not just possible, but practical. The implications extend far beyond low Earth orbit. V3's capabilities are essential for establishing a permanent human presence on the Moon through NASA's Artemis program. But the real target lies further out: Mars. SpaceX's vision of Martian colonization requires thousands of flights during each 26-month launch window. V3's increased capacity could reduce this number dramatically, making the dream of a multi-planetary human species more achievable than ever. Every aspect of V3 has been optimized for this grand vision. The improved heat shield system isn't just for Earth re-entry, it's designed to withstand the unique challenges of Mars's atmosphere. The enhanced fuel capacity isn't just for reaching orbit, it's calculated precisely for the journey to another planet. Even the navigation systems are built with interplanetary travel in mind. The development timeline for V3 reflects this urgency. NASA's Lisa Watson-Morgan's hint at a year-end debut wasn't just speculation. It was a recognition of the rapid progress being made at SpaceX's facilities. Engineers are working around the clock, pushing the boundaries of what's possible in aerospace engineering. But before V3 can take flight, SpaceX must perfect V2's systems. The current version has already demonstrated several crucial advances: the adherence of new heat shield tiles, the efficiency of redesigned forward flaps, and the raw power of its enhanced engines. These successes provide the foundation for V3's revolutionary capabilities. The path forward is clear but challenging. SpaceX must master critical operational milestones, including the complex process of catching super heavy boosters with the Mechazilla system. They must perfect orbital maneuvers, payload deployment, and in-space engine ignition. Each success brings us closer to V3's debut, and each setback provides valuable lessons for the future. As we stand on the brink of this new era in spaceflight, the significance of V3 cannot be overstated. It represents more than just technological advancement. It embodies humanity's eternal drive to explore, to push boundaries, to reach for the stars. With V3, SpaceX isn't just building a bigger rocket. They're building a bridge to the future, one that could finally make us a truly spacefaring civilization. The road ahead won't be easy. The technical challenges are immense, The risks are real, and the competition is fierce. But SpaceX has never shied away from ambitious goals. V3 stands as testament to their commitment to revolutionizing space travel, making the impossible possible, and opening up the final frontier to all of humanity. As we watch V3 take shape, we're not just witnessing the evolution of rocket technology. We're seeing the future of human exploration unfold before our eyes. Each advancement brings us closer to realizing dreams that have inspired generations. Sustainable lunar bases, Mars colonies, and perhaps one day journeys to the outer reaches of our solar system. This is the promise of Starship 5-3, not just a bigger rocket, but a gateway to the stars. Through its development, testing, and eventual flight, we're not just pushing the boundaries of what's possible in aerospace engineering. We're redefining what it means to be human in the space age, writing the next chapter in our species' greatest adventure. As Starship 5-3 takes shape at Starbase, it represents more than just SpaceX's next giant leap. It embodies humanity's boundless ambition to explore the cosmos. With its unprecedented fuel capacity, revolutionary refueling capabilities, and groundbreaking engineering, V3 isn't just changing the game, it's creating an entirely new one. The message is clear. We're witnessing the birth of true interplanetary spaceflight. From lunar missions to Mars colonization, V3 will serve as the foundation for humanity's greatest adventure. Each technical breakthrough, each successful test, brings us one step closer to becoming a multi-planetary species. What are your thoughts on Starship V3's capabilities? Share your views in the comments below. If you're as excited as we are about the future of space exploration, hit that like button and subscribe to Elon Musk 24 Hours for the latest updates on SpaceX's groundbreaking developments. Don't forget to hit the notification bell to stay informed about all our upcoming coverage. Until next time, keep your eyes on the stars. The next giant leap is closer than you think. In 2023, a team of veteran aerospace engineers gathered at a conference in Houston. The topic? SpaceX's Starship. One by one, they laid out their concerns. Too complex, unnecessarily large, won't survive Mars re-entry. The room buzzed with skepticism. Meanwhile, at SpaceX headquarters in Hawthorne, California, another Starship prototype was taking shape. The world's largest rocket, standing taller than the Statue of Liberty, gleaming in stainless steel. A rocket that breaks every conventional rule in the aerospace handbook. The debate rages on. Robert Zubrin, president of the Mars Society, warns of deep craters forming under Starship's powerful engines during landing. Peter Beck, Rocket Lab's founder, questions the very economics of Mars missions. Even NASA veterans scratch their heads at the complexity of orbital refueling. But here's what's fascinating. While some of the most experienced minds in aerospace raise red flags, others see Starship as nothing short of revolutionary. Dr. Ali Bramson from Purdue University calls it a complete game changer for solar system exploration. NASA scientists are already planning experiments that were impossible before, like sending full-size drilling rigs to Mars. Today, we're diving deep into this controversy. We'll examine why some of the brightest minds in space exploration are divided over Starship, what the critics are missing, and why this massive rocket might just rewrite the rules of space travel. Welcome to Elon Musk 24 Hours. Let's dive right in. The story of Starship begins with a question that haunted Elon Musk for years. Why aren't we already on Mars? It's a question that led SpaceX down a path that traditional aerospace companies considered impossible. But to understand why Starship has become such a lightning rod for controversy, we need to look at what makes it fundamentally different. In the halls of NASA's Johnson Space Center, there's a full-scale model of the Apollo command module. It's tiny, barely big enough for 3 astronauts to squeeze into. Now picture Starship. Its crew compartment alone is larger than the entire International Space Station. When Robert Zubrin first heard about these dimensions, he thought it was a mistake. It's like building a cruise ship to cross the Atlantic when we barely have working sailboats, he said in a 2022 Mars Society conference. But here's where the story takes an unexpected turn. That massive size isn't just ambition, it's necessity. And it all comes down to one revolutionary idea that SpaceX refuses to abandon: in-orbit refueling. Think about this for a moment. Every other rocket in history has been designed to make a single trip with all the fuel it needs. Starship? It's designed to be a cosmic gas guzzler, meeting up with tanker ships in orbit to fill up its tanks. It's like building a network of gas stations in space. When Peter Beck from Rocket Lab heard this plan, he was skeptical. Tens of thousands of launches, he said, shaking his head.